Thank you so much, Mr. Hamish. Thank you, and wish you all the best with your hard work. And I just want to say we appreciate you, and I have achieved like 93%. Sanbonani. This is Emma Onokulawam Kizismongo. I live in Devon in KwaZulu-Natal, and I was born in KwaDlabisa in KwaZulu-Natal.
Hello, how you doing? I'm Hamish. Let's get started. So if you FaceTime, make sure you go and visit my website, and don't forget to do your donation, because with the donations, that's what make this project going, and it helps me to get equipment and get pens and white balls and keep this project going. You know what I'm saying? We need equipment and all this stuff. So just go visit my website, and also do donation, subscribe, and share this video to a lot of people. Don't forget to subscribe and share. Let's get started, okay? I'm Hamish. So now we have a question right here. So this is more, let me try to break down quick. I'll break down so you can get to understand. Either you know or you don't know anything about physics. I'll take you from beginning to where you can be able to do this question as fast as I can. Look, so let's say this is a mountain, okay? So there's a plane here. Now let's say you drive a car, and then right here at the corner of the mountain, there's a hill. You know what I'm saying? So now you're climbing the hill. So if you're climbing the hill, means this is, let's say, a car. Okay, so which force is going to, okay, so now this is the horizontal. So you're supposed to go this way, but just because there's a mountain, so you cannot drive. That means you have to drive on top of the mountain. So there is an angle theta. Means the angle theta is between the inclination of the mountain and horizontal. Okay, so now this is a triangle. Let's say this is a triangle. Let's connect it. Let's make a triangle. So if this is a triangle, we know for effects these are adjacent. These are adjacent. The horizontal is the adjacent, and this is opposite. So this is the opposite, and this is adjacent. So Mathematica, okay, so we're going to say this car here is going to have a weight, is going to have a gravity, force of gravity. Force of gravity is always acting vertically down. Vertical down. So we're going to call this force of gravity. You understand what I'm saying? Force of gravity always act vertical. That's why we have it orange. If you throw the pen up, what happens? It comes down, because an object, it has a force which acting toward the center of the earth. Now, you see this surface here? If you have a horizontal surface like this, let's say a table, and then you put it back, so what happened? These you're going to call it what? Force of gravity. You see? And the force which is opposing, we're going to call it what? Force of normal. Or sometimes they can call reaction force. Because there's a force which acting toward the table. This is the table, but from the table, right here from the table is going to be opposing and act what? Opposite direction toward the box or whichever object which is in here, okay? So now same here. So the force of gravity, it acts vertical downwards, okay? So now, where is the surface? This is our surface here. You see, this is our surface. So it's going to be a force which comes from the surface of the mountain or whichever ground or whatever toward an object. But what is the object? A car. So for this case, the inclination means the force is going to come from the surface toward the car like this. So this is going to call force of normal. You know what I'm saying? So now let's resolve. So to resolve means prolonging. Prolong this one. Prolong. Okay, what do we mean this one? Okay. So prolong it. And then when you prolong, okay, now you have to connect this triangle. But how are you going to connect? Don't worry about this. How are you going to connect this triangle? This triangle, you see this? This is very, very careful, guys. Okay? Pay attention. You see this line here? The line you're going to join here must be parallel with this. What is parallel? Parallel means two lines that never meet. Like, you see? These are parallel lines. You see? These are parallel lines. Means if I had to connect this, it must be parallel with this line. So this line goes this way, so I must connect also the same direction. So if you connect like this, you're in trouble. Wrong. Means it must be parallel with this line. Can you see? The parallel. Now, so if this egg down means this connect this direction and this connect this direction. Look, down, this way, and this way. Okay? So now remember, this angle is going to be same with this angle. You know what I'm saying? This angle is going to be the same with that angle. Means from the similarity, means this angle must be the same with that one. Now, so this is a triangle we have. Excuse me, the triangle we have. So this triangle, this new triangle we have, we get from this one, from the law of similarity. So this is adjacent. For this new triangle, can you see the angles like they take this triangle? So this is adjacent here. This is adjacent. So adjacent, we know any adjacent mathematical and trigonometric is cos. So what you do, you take whatever you have in it. Okay, let me just show you this quick. Some people don't know. Maybe they will say, oh, I'm kind of confused. Okay, if this is a right angle triangle, see. So this is hypotenuse. Hypotenuse, this is adjacent, and this is opposite. Okay, let's say somebody give you this triangle now, and then they give you some data. Let's say this is 6 kilogram or just 6. They say, okay, they give here theta. They say find the opposite and find the adjacent. You see, this is opposite. Opposite means something which is vertical. You see what I'm saying? So now we're gonna say, okay, now let's get it. So let's start with adjacent. Adjacent is always cos. Just simple like that. Adjacent is cos. So I'm gonna say cos of angle, cos of whichever angle is here, multiplied by hypotenuse. This is hypotenuse. So you multiply by, what is hypotenuse? 6. So that's how you get your adjacent. But for hypotenuse is sine. So we're going to say hypotenuse is sine of angle and then multiply by hypotenuse. What is hypotenuse? Is 6. So remember that whenever you have a triangle, adjacent is cos, hypotenuse is sine. But you must multiply by the hypotenuse. Now, so if you look careful this triangle here, so face, excuse me, let me say it again one more time. If you look at this triangle, look, where is your angle? This is your angle here. You see, it's like, look, this is your angle. So this is hypotenuse. It's like the turn. This is the hypotenuse. Look, let me turn. Let me turn one more time so you can understand. If somebody give you this, let's say, I'll come here, guys. I want to make sure that you understand. Okay, now this is the angle here. Let's say this angle alpha. So which is hypotenuse? This is hypotenuse here, the longest length. So this is hypotenuse. Okay, let's say 7 kilogram. Oh, so that's hypotenuse. Okay. Now, which is opposite? Opposite is something which is vertical. So this is the opposite. And this one is adjacent. So opposite, we know opposite always what? Sine. Opposite sine. So here I'm going to say this is going to be sine of my angle, but you must multiply by the hypotenuse. Oh, so this is, we got it already. But if adjacent is cos, so I'm going to say cos of my angle, and then you must multiply by the hypotenuse. You see what I'm saying? That's how you get that. So now, if you come careful here, it's the same thing. You see, this is hypotenuse, but look, this is hypotenuse. But hypotenuse always, it make an angle with the adjacent. Hypotenuse and adjacent, they always make an angle in a triangle. So, hypotenuse, can you see? This is hypotenuse and adjacent. Oh, that's how I knew. Oh, yes, because whenever there's an angle, means there's a hypotenuse and adjacent. For this case, this is a little trick I'm giving you, right? So now, this is going to be hypotenuse and this is going to be adjacent. But what is adjacent? Adjacent is cos. Adjacent is cos. So here I want to say this is cos of angle. Multiplied by the hypotenuse. What is hypotenuse? FG. Okay. So whenever there's a hypotenuse and angle means, whenever there's an angle means adjacent and hypotenuse. Now, so this is going to be opposite. So opposite is sine. What is the angle? Angle theta times by hypotenuse, which is FG. You see what I'm saying? So that's like that. So you have to remember that. So now from Newton's, oh my God, where is my, just a second guys. I'm trying to look at my one of the ways. Oh, I got it sorted with it guys, okay? Now, from Newton's second law of motion, say, from Newton's second law of motion, say, net force, first net force equal to mass times acceleration. Oh, what is net force, sir? Net force, okay, look. The net force is, look, for example, this is me right here. This is me. And let's say we're pulling the rope. And you here, and with your friends, you're both holding the same rope. So, you have, let's say, 3 Newton, and your friend have a 2 Newton. Me have a 7 Newton. Now we pull, what happened? Oh, no, let's make 5 Newton. So what happened? I mean, we know we're not going anywhere because you guys are pulling and pulling, but we have the same force. Your force going this way, let's call it force 1, and my force go this way. So it's like we're not gonna move. We're gonna be like, you know what I'm saying? Not moving because we have the same force, because we don't have a net force. So my force minus your force is gonna be 0. So now I decided, like, you know what? Now I'm wasting time. Let me call my friends. Hey, come and help me. Shaka Zulu, come and help me. So Shaka Zulu is gonna come here. So let's say, oh, this is 4. So Shaka Zulu come is, let's say, 3 Newton. So total of my force. So where this gonna be moving? This way or this? Of course, it's gonna be this way, because the total force of this side is 80 and this is 5. So 8 is bigger than 5. So which force made me and Shaka Zulu pull you guys is only 3 Newton, because that's the extra force or net force. You know what I'm saying? So for you to get net force phase, you have to know where the direction where things are moving. So for this case, the rope, or we pulling you guys, okay? Oh, so I'm gonna say force net equal to this force phase. You have to look at the direction, and you look, oh, you move this way, so it's gonna be 8, because 3 and 5 is gonna be 8 Newton minus 5 Newton. It's gonna give us 3 Newton. So our net force equal to 3 Newton. So we take all the force minus anything which is opposing. But at phase, you have to know the direction, like where is it moving, and then you take that force where it's moving minus anything which is opposing. For example, you decide, like, oh, you know what, I'm gonna call Mansa Musa. So Mansa Musa is gonna come. So let me come and help. So this is Mansa Musa here. He came from Mali, the richest man on the earth, on the planet Earth. So he's gonna come and help you guys. But this Mansa Musa only have 1 Newton. So still, we're gonna have more force, because me and Shaka Zulu, we have 8. You guys are gonna have it. This 5, 6. You're gonna have a 6. So our net force, you take phase, you have to do like direction, and then take the sum of all where object is moving minus anything which is opposing. So now let's come here now for that case here. So now we're gonna say net force. So first and foremost, I'm gonna have to look for the direction of this object. The direction tells me which force is bigger. So now if you look careful, this object is going to be moving up. So since this object is going to be moving up, means, let's say this we're going to call force of engine for this case, force of engine, because it's the car. But if you pull like here, means force applied, because you pulling force. So now we're going to say for this case here, if this object moving this way, we know we're going to have a friction force on the surface here. See, we're going to have some friction force, which, you know, that's why the tires sometimes get finished, because we have a friction force. So we're going to call what? Friction kinetic. Kinetic is something which is moving. So this is going to be friction, kinetic friction. So now we're going to say, okay, now force net from Newton's second law of motion. From Newton's second, don't forget to write this, second law of motion. We're going to say force net equal, now you have to look where this object is moving, down or up. Is moving up. Oh, so we're going to say force of engine, any force which is opposing, or any force which is supporting this. No, it's only engine of a car. So only force of engine. What is that opposing? Force of kinetic friction is opposing. Oh, so we're going to say, oh, force of net force equal to force of engine minus all the forces, all the forces which is opposing. Which force opposing? Kinetic friction. Which other one? This also the force is called parallel force. You know what I'm saying? Because we resolve this force from force of gravity. So this force here, look, the direction is moving down. So do not forget this. We call it decelerating force. So this force we call it decelerating force. Decelerating force. Decelerating force. So this is decelerating force. So we're going to say kinetic friction is this, and which is opposing? This also opposing. Fg, which call sine of angle. So for this case, this what's going to give us net force. But net force is mass times acceleration, because from the Newton's second law of motion, it's supposed to be like this. You must say force net equal to mass times acceleration. So all this stuff means ma. So I'm going to say Fe means force of engine minus, what is that force? Force of kinetic plus Fg sine of angle equal to mass times acceleration. You know what I'm saying? And another thing is not. Whenever object move with a constant velocity, this is a big note. Constant velocity. When object move with a constant velocity, always note your acceleration equal to 0. Means object does not move. When object move with a constant velocity, acceleration equal to 0. What that mean? Listen. We know, guys, I just want to give the overall pack. Okay, so when you come here, you can see how easy it is. Excuse me. So look. So we say, why do we say when object move with a constant velocity, acceleration equal to 0? Listen. Acceleration always equal to change in velocity over time. So when object move with a constant velocity, means when you say change in velocity means velocity final minus velocity initial divide how long does it take. Let's say take 20 seconds. So acceleration equal when an object move with a constant velocity means when you start your journey or when you drive from where it begin and where it finish, it move with a constant velocity. Let's just start with 100 meter per second. And then I'm going to drive with 100 meter per second. So I'm going to say velocity final means 100 meter per second minus velocity final means this is velocity final. Velocity initial started also with the same velocity because we say constant velocity means minus 100 again meter per second. And then we divide, let's say 20 seconds, you can make time. But 100 minus 100 equal to 0. So 0 over 20 equal to 0. So my acceleration equal to 0 meter per second squared. Can you see? So if an object moves with a constant velocity, means it does not accelerate. That's why I say here when all constant velocity acceleration equal to 0 means, let's say this car is going to move with a constant velocity from here beginning to finish, means when the car does not accelerate. And when car is at rest, also it's not only there, even when it's at rest, when at rest means we know v equal to 0, so the object does not accelerate equal to 0. So this condition you have to pay very attention. You know what I'm saying? So this is the situation where only one object is not attaching or is not towing, is not pulling another car, just only one object. You see what I'm saying? So I believe you have some kind of clarity. One more thing, let me add. So I'm going to raise this. Oh, let me write here. So we say, just a minute, sorry, just a minute guys. Okay, just a second. I want to show you this is very important. Just a second. Notes. Force of kinetic is always equal to kinetic friction times normal force. You better note this. Never forget this. Forget, you're in big trouble. What does that mean, man? Listen. So you see this what we have? You can come and replace this. And you can say force of kinetic equal to okay, this is coefficient. This is coefficient of kinetic friction. Coefficient. This is a coefficient and this is normal force. Force of normal or normal force. So these coefficients and this is the force of normal or normal force. So now you might come and replace these. But look, so you're going to say force of kinetic equal to, okay, what are these? These most of the time they give to you. So say force of kinetic equal to coefficient. So you memorize these. Sometimes they give to you, but I'll say memorize. Equal to kinetic friction. But look, if you look careful here, look, normal force we know. Okay? What is normal? This is a force of normal. So it's equal to what? Look, this is equal to this force here. Oh, so only in inclination. So I'm going to say this force of normal equal to Fg cos theta. Oh, so force of normal equal to Fg cos theta. Okay, so now I'm going to move this. I put Fg cos theta because look, same thing. F of normal equal to this. See, same line. Force of normal equal to Fg cos theta. Oh, okay. So now I can take all this and substitute there. Guys, this is very important. So I'm going to say, okay, force of engine minus, okay, Fk we have force of kinetic equal to coefficient times Fg. But we know Fg. Fg, force of gravity. Force of gravity always means mass times gravitational force. Guys, this is a formula. Physics has a lot of formula and you memorize. Means if you want to get force of gravity, take mass of object time is gravitational force, which always constant 9.8. So we're gonna say, oh, okay. So now over Fg, I'll say, okay, this is mass of a car times its gravitational force, which is 9.8. So mass of a car they're gonna give to us. Now, and then you multiply by, see, we replace this with that, and then multiply by cos of angle, whichever angle they give to you. Oh, so I'll replace this with this. Now we plus with plus. Fg. Oh, Fg also we know. Mass times gravity. So I'm going to say this is mass times gravity. Means mass of a car times gravitational force. Okay? Now, so we have to replace this sign of whichever angle they're going to give us here. Okay, what else? I have, okay, now, and then equal to mass. So it depends. If an object moves with a constant velocity, we know acceleration is going to be equal to 0. Means 0 times m equal to 0. Only if they mention, but if they don't mention, means you have to wait for something. Now, let's go to that question right here. You know what I'm saying? I believe you have a lot of idea what happened. So now we're going to say, easy, man. Look how I'm going to break this. Easy, very easy. Oh, the Cubs, man. 5-0. It's 5-0. Cubs everywhere. I don't know what happened. Okay, sorry guys. I'm trying to do something better for you. Okay, now, from the question here, the first question they say, phase, state, Newton's first law of motion. Listen, man. You see this stuff here? Oh, let's say this whiteboard. You know, if I can live here and then come back after 10 years, this whiteboard is supposed to be here. But the whiteboard might fall. But how is it going to fall? Maybe the wind was blowing from my room or whatever, and then kind of disturbed this, and then the whiteboard fell. Or somebody came here and then pushed this whiteboard. The whiteboard is going to move. Otherwise, it has to stay here forever. That's how the Newton first law say. It means an object will remain in a state of rest. It means it's going to be there forever. Okay? So it's going to remain in a state of rest. Or, if I take this pen, look, for example, I'm throwing. Why does it stop? Because there's a whiteboard which is tapping. There's a wall or whatever which is tapping. So this you were supposed to move forever, but it's tapped because of the whiteboard. So whiteboard in physics we call it what? External force. External force, you know what I'm saying? It's been acted on this pen or whichever objects. So if I have a ball and then I threw the ball, so maybe the ball just going then it to do the speed because remember the wind or somebody's tapping. So those which tap it or the wind or whatever, we call them what? External forces. Okay, so we expect the ball, according to the Isaac Newton, the ball was supposed to go forever, like the same speed. But why did it do the speed? Because of the external factor, external forces like a wind, somebody's tap or whatever, or maybe hit the wall. So those external forces. And why this maybe has to be stay here forever? If I take maybe this cloth here and leave here, it's supposed to be here forever. Why is maybe it's going to be moving there after 10 years after maybe tomorrow when I come back? Because there was a wind, maybe somebody replaced. So those we call them external factor, external forces. So according to the Newton first law of motion, you say, according to the Newton first law, Isaac Newton first law, you say, an object will remain on a state of rest, means supposed to be here forever. Or uniform motion. Uniform motion means it has to be steady motion forever. Okay? It has to remain in a state of rest or uniform motion. Unless it's been acted, means it's been acted with it by external force. Otherwise, maybe it has to be some external force which causing either to stop or to move or to get disturbed. So that's how the phase Newton Isaac started. You know what I'm saying? So that's how you do. Now, the second question say, excuse me. Sorry guys, just a second. Okay, got it. The second say draw label free body diagram of block P. Free body diagram of block P. So before you draw free body diagram, me patient will say do face force diagram. Force diagram is what I did before. They didn't ask you that, but I will do face, because when you do force diagram, you're done with all the business. So I'm gonna do, they say free body diagram, right? Okay, let me do force diagram. So I'm gonna do force diagram. The one free body diagram. Excuse me guys, let me drink a water a little bit and feel taste. So I'm gonna do force diagram, okay? Okay. So let's do force diagram. The one free body diagram, let me start with the force diagram. Okay, so now I'm gonna redraw this. I can just do right here. I don't have to redraw another one. Okay. Look. So we know for facts, we're going to have a force of gravity here, which is acting vertical downward always. Vertical downward, force of gravity. And then another thing we're going to have, look, so we know we're going to have a force of normal. Where is normal come from? Normal come from the surface where the object lies. So this box here, whatever you have here, is going to be lie on this ground, which has been inclined by the 30 degree. So we're going to say force of normal is going to come from the surface toward the object, vertical. And it must be angle 90. Look, this angle 90. Angle 90 means 90 degree. Means, look, this surface and normal, it always make angle 90. Remember the guys, never do this. Never do this. For example, say, wrong. This is wrong because it does not make angle 90. It must be surface with a normal force always make angle 90. So if it was like this, for example, and the normal force, look, this force of gravity. So normal force, it was going to come from the surface, because force of gravity come from the center of object downward, vertical downward. But normal force, it come from the surface here toward. It must be angle 90 with the surface. You see, angle 90, force of normal. But for this case, because inclination, look, so that's why you say, okay, surface, you see, angle 90 here. Now let's go. So we have to resolve it. Look, I'm going to do. Now, this angle must be equal to this angle, which is 30 degree. So now we got triangle here. This 30 degree. My God, let me write my 30 degree. So let's connect our triangle now. How am I going to connect? I know this line and this must be parallel. This and this must be parallel. Okay. So this is going to be like this. Parallel. These, look, must be same. Oh, so it's going to be like this. So now, you see we got triangle here. So we know whenever there's an angle means hypotenuse and adjacent. Oh, adjacent. What is adjacent? Adjacent is cos. Adjacent is cos. Adjacent is cos. Cos of angle. So I'm going to say this is going to be cos of my angle, which is 30, multiplied by the hypotenuse, which is FG. Or you can even say MG. Now we come here. So what happened here? Oh, this is opposite. So opposite is sine. Opposite is sine. So this is going to be sine here of my angle, which is 30, and then you must multiply by the hypotenuse, which is FG. You know what I'm saying? But if this object was pulled, or was pulled, or you can say pulled or force applied, means there's a friction force which is opposite. Friction force also always opposes the direction where the object is going to. So if this object goes that way, if friction force is going to be opposing. So friction force acting this direction. Friction of kinetic, because object is moving. Now, so we have all the force we need. And according to this object, they say draw free body diagram of this. Free body diagram meaning, look, let's draw free body diagram. So you want to come here, look, you draw those actual force. So free body diagram, I'm going to say, see, this is an object. You don't have to draw the whole object. You put like dot, dot, and arrow. This is 80 kilogram. Okay, which force you have? This is a force face. Force, the face force. So look the direction. You must draw the same here. Same direction. Oh, and this is going to say force of normal. Let's say here force of normal. Okay, which other force? This is the actual force, force applied or pulling force. Okay, which other force? Force of kinetic. Which other force? Force of gravity. I made a mistake here. Since this is a force of gravity, it must be solid here. So force of gravity, same direction, guys. Okay, so do not take these two because these are components of the force of gravity. So don't take them. You know what I'm saying? When you draw free body diagram, you don't need these because you got these by resolving the actual force, which is Fg. That's why you got Fg sin theta and Fg cot theta. So these are free body diagram of 8 kilogram. This is 8 kilogram. And now you have to say Fn is normal force, whereby Fn is the normal force. Okay, F, force applied or pulling force. For this case, somebody was pulling it. But if we use the car, you was going to say force of engine. So say force applied or what, or applied force. Force applied or pulling force. Pulling force. Okay, Fg, force of gravity. Force of gravity. Guys, sorry man, I don't have a good hand. Gravity, my handwriting is not so good. Force of gravity, another force. Kinetic friction, force of kinetic friction. Kinetic friction force. Kinetic friction force. You see what I'm saying? So we have all the force. 1, 2, 3, 4. Yeah. So now let's go for the second question. The second question, let's see. So I'm gonna erase this stuff. I don't need them anymore. Okay, now let's go for the second question, right? Okay, the next question is say kinetic friction force between the block and the surface inclination is 20.37. Oh, so they give us here kinetic friction force. Oh, 20.37. So they give us here force of kinetic equal to 20.37 Newton. This is a force of kinetic. Oh yes. And then they say calculate the magnitude of force. So kinetic friction force between the blocks and the surface means between this block and surface, this kinetic friction force equal to 20.37. Now what do they want? They say find calculate the magnitude of a force. They want us to find this force here. What is this force? So you know what you're going to do? Most of this question here, whenever they ask you, start from the Newton's second law of motion. For Newton's second law of motion, from let me do here. Yeah, from Newton's second law of motion. How do we say it? We say F net means force net equal to mass times acceleration. Brother and sister, this has to be like 1 plus 1 in Newton's law question. Now we go, what is F net? F net means first you have to look the direction where this object is moving. Where is it moving? It's moving up. Oh, so this object accelerating to the top means this is acceleration to the top. Okay. So which force is bigger? Means this is bigger. That's right, going to the top. So I'm going to say force net means this is a bigger force minus any force which is opposing. Which force opposing? Force of kinetic plus which other force opposing? Fg sin theta, because look, this way and this way. Oh, plus Fg means this, and then you minus all the one which is opposing, Fk and Fg sin theta. You see the move in this direction. Fg sin of theta. Okay, we don't have no other force, so equal to mass times acceleration. But now let's go to the question. Did I mention anything when it has to do with the constant velocity now? Now, if you go to the question carefully, they say on top, they say constant speed. You see, they say at 2.1, 80 kilogram block is being pulled at the constant force up to the rough inclination and inclined plane at angle 30 to the horizontal at constant speed. Okay, at constant speed. So we know what the constant velocity or constant speed acceleration always equal to 0. Oh, so this is going to be equal to 0 because it's going to be A equal to 0. 0 times A equal to 0 times mass equal to 0, because this is not going to matter. It's going to be 80 kilogram here mass. 80 times 0 equal to 0. Okay, now I'm looking for the F like how they asked. Fk how? Equal to 20. So I'm going to say this equal to 20 plus 37 plus Fg. Fg means time, mass times gravity force. See, this is gravitational. And then sine of 30. But always sine of 30 equal to a half, equal to 0. So this is what I'm looking for. So I can take everything to the right if I want. But I know mass equal to 80 kilogram, and the gravitation is constant 9.8. They're gonna give to you this. You have to know actually. So we're gonna say, okay, my F equal, see, let me go step by step. Minus 20.37 plus mass. Mass is 80 kilogram multiplied by G. G equal to 9.80. Sine of 30 equal to a half. So it's like a half is 0.5. You can say that equal to 0. So we're gonna add all these, and then again force equal. So let me take all these to the right if I want. So if you take all these to the right and it's negative, and the jump equal sign is going to become positive. So we're going to have here 20.37 plus 80 times 9.8 times 0.5. And this is going to give us a force which is pulling the object equal to okay, just a minute. $59.57. Oh, this will give us 59.57, but our force, the unit of force is Newton. We don't know that. Now, so this force now we know for this case, if this has to move up with this friction force of 20, the force has to be 59.57. Now let's go to the next one. So the next one they say, now they say force F is removed. Means they say, you know what? We're gonna remove this now. It's crazy, man. So remove this force now. So if you remove this force, means there's a chance this stuff is not gonna move up. Because now who's pulling? Nobody's pulling, so it's not gonna move up anymore. So we don't need this anymore. You know what I'm saying? Okay. Because we already got it. Okay. So now we remove the force. So if we remove the force, okay, before we go to the question, what's gonna happen here? If you remove the force, meaning, if you remove the force, what happened? If I remove the force, meaning where this object is moving, it's going to start to slide down. So if it's going to start to slide down, means the kinetic is not going to act this direction anymore. Because kinetic always is the friction force which is opposing where the object is going to. So if nobody is pulling this up, means we know it's going to start to slide down now. So the kinetic friction or friction force is going to be acting opposite to where, because object is moving down, so kinetic is going to oppose. Okay. So and then, so now if I had to ask you now, which force, okay, which force is going to be acting this direction? The force which is going to act in this direction is this force here, only this force, because look at the arrow, it's Fg sine theta, or sometimes we call it decelerating force. So only one force here, because nobody's pulling, it's just falling itself. It's like a ball on a hill, it just falls itself. So what caused the ball fall is decelerating force. Decelerating force. You know what I'm saying? So which is Fg sine of angle, but for this case is sine of 30. And which force opposing? Force of kinetic. Now, what is the question? The question they say, Fg is now removed and the block accelerates down the plane. The kinetic friction force remains. So kinetic friction force remains the same, which is 20. This is going to be the same, 20.37 Newton. Now, what do they want? They say, now find the acceleration. Find the magnitude of acceleration of the block. How is going to be accelerated this time? We need to know the acceleration. So now it's not going to be zero anymore, because we say at that phase time it was moving up with a constant velocity. So they taught us there already, but now they didn't tell us anything. They say find this acceleration. We can get it easy. So like I said, this question you start here. Force net equal to mass. how are we going to get net force? To get net force, look where this object is moving. Is it moving up or down? You have to know the direction, brother, sister. Okay? Okay, king and queens. So now, which direction? The object is moving down. Which force make it moving down? Decelerating force. Okay, so to get F net, I'm going to say where is it moving down, but the force which is making moving down, decelerating force, which is what is Fg sine theta, sine of theta for this case, minus any force. Okay, this is only force. Which force opposing? Only one, which is what? Fk. Do you have any other force maybe move? No, we don't have another one. It's moving this way and this one opposing. So you have to look direction equal to mine. And this is what we're looking for, acceleration. So we have most of the stuff here. They say this is going to remain the same according to the question. G, we know Fg means mass times gravity, and the sine of 30 minus Fk, which we know 20.37, and then mass we have, mass is equal to 80 kilogram. So m times a. So we're looking for the acceleration. Easy, man. Now let's go. So if I look for acceleration, mass we have 80 kilogram times g. G is 9.8, is a constant. Sine of 30. Sine of 30 is a half or 0.5. Minus kinetic friction force, which they have. They say this is going to remain the same. Equal to mass. Mass equal to 80 times acceleration is what I'm looking for. So this is what I'm looking for. So how am I going to get it? I have to take this stuff, divide by 8. So I'm going to say 80 times all this minus this divided by 8. So minus, get the answer, and divide by 8. So take a calculator. So it's acceleration now equal to all this stuff, which is 80 times 9,80 times 0.5 minus 20.37 divided by this 8. Because we want to get acceleration. So my acceleration equal to all of this and get the answer. And the unit of acceleration is meter over second square, or sometimes you can say it's meter second negative 2. This is going to give us acceleration. So plug in a calculator, and this is going to give acceleration of 2.35. So acceleration is going to be 2.35 meter per second. Sometimes you can get negative or positive, but I want you get acceleration equal to negative 2.35 either the other. If you get negative, means that tells you this object, of course we're going to get negative here because this time this going to be 72. No, it's positive, sorry. So it's positive, sorry. So meaning your acceleration equal to 2.35 meter per second square. 2.35 meter per second square. Okay, now, so we have acceleration when this force is being removed. So it's going to accelerate with this acceleration. Now, it's just a waste of time. You do this question, and it's easy like that, man. Thanks a lot. You know what I'm saying? Look, man, I believe in learning from how I do things. If it's make sure you subscribe, and you know, you can just go and do donation to our Patreon page. I have a Patreon, I have a GoFundMe. You know what I'm saying? I have all the means of donation because to make this project going, you know, any type of donation, the little that you think is too small for you, it could make a lot of change. And thanks a lot for all your time. You know, subscribe, don't forget, share this video, circulate to a lot of people, you know, because the meaning of this project, this program, is to help as many as we can. Okay, it's not only for one person or two, because you might think it's not helpful for you, but for somebody next out there, it could be very, very helpful. So thanks a lot, man. And you know, any donation that you did to me, it means so much. I appreciate it, man. It means a lot. Go to our Patreon page, go to our GoFundMe, because we need to have a lot of things. We need to put them together, like camera, you know, and a lot of equipment, so that we can improve on, you know, a lot of angle, a lot of aspects of these projects. You know, thanks a lot, man. I appreciate and I love you. Peace and love. Bye. You know, this is one of my students of knowledge. You know, she wanted to introduce herself. What's your name? Could you please introduce yourself?
My name is Kali. I went to Southend Primary School.
Yeah, Mtwana wa Bantu. Mtwana wa Bantu is everywhere, right? So this is my other student. His name, what's your name?
Matthew.
Matthew, yeah, he's grade 11, man. So his aim is to score distinction, right? So you promise, I want you to score distinction this time. And what's your name?
Joshua.
Joshua, how much you promise me to score this time?
Distinction.
Distinction. Yeah, so Mtwana wa Bantu is everywhere, man.
Mtwana wa Bantu.
Mtwana
wa Bantu everywhere.
Everywhere.
Mtwana wa Bantu
everywhere.